Organic chemistry is a science that is based on the basic unit of life in Earth, carbon. Fewer than 200 years ago, it was thought that only living organisms could synthesize the carbon compounds found in their cells. So these compounds were classified as organic compounds, and the study of these compounds are organic chemistry. A German chemist, Friedrich Wöhler, refused this idea in 1828. He was able to use inorganic substances to synthesize the urea A carbon compound found in urine. Today, organic chemistry includes the inorganic and organic compounds, almost all carbon compounds, regardless their origin. There are more than a million organic compounds. The basic and the most simplest carbon inorganic compound is hydrocarbon that contain only one carbon and one hydrogen. In the classification of hydrocarbon, we can find in the aliphatic way alkanes, cycloalkanes, alkenes, and alkynes. Alkanes are single covalent bonds, uh, which we have the ending with A and E. Now the way names of the alkanes are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. These are in the way from 1 to 10. The properties of alkanes are nonpolar compounds, insoluble in water, less dense than water, so they can float on the surface of the water. They can dissolve in organic solvents and each other, and they have a lower melting and boiling point. Now we are going to discuss about alkenes. They are hydrocarbon that contain a double covalent bond. The way we call this, or the name of the alkenes, are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. The properties of alkenes are insoluble in water and soluble in polar solvents. Density is less than waste. The boiling and melting points of alkene is usually lower than the alkane with same number of carbon atoms. Alkane with 2 to 4 carbon atoms are gases at room temperature. Unsubstituted alkenes with 5 to 17 carbon atoms are liquids. Alkenes with greater 17 carbon atoms are solids. Now we are going to discuss alkynes that are hydrocarbons with 3 bonds. The names are ethane, propane, butane, pentane, hexane, octane, nonane, and decane. The physical properties of alkynes are they are nonpolar and insoluble in water, soluble in most organic solvents. Boiling points are similar to alkane of similar size. They are less than the water and up to 4 carbons gas at room temperature. And as last one, we have the cyclic hydrocarbons that are carbons in the form of a ring. These cyclic carbons, they're only the structural form, they are like the geometric figures, as for example, as cyclopropane that has 3 sides with about the 3 carbon it have. So the structural formula it has as a structure as a triangle, and the line formula, as I have said, is a line triangle. The naming of compound always change. For example, we have many different ways to call or to find carbons or to draw it. The ways we can do it are with molecular formula, for example, C4H8 and O2. The empirical formula that is almost the same, so we can't name or set a number of oxygen. The condensed formula is the way repeated about carbon and hydrogen. For example, CH3, CH2, CH2, COOOH. The display formula is the most simplest way about organic chemistry. In the way we show how many hydrogens are needed to form the 4 hydrogens needed on the carbon. The structural formula we show the way in which they are written. Now with hydrogen mixed with carbon, for example, and this figure that we showed that carbon is on it. A skeletal formula is the last one. In the way each point it shows a carbon. In what it breaks the line, it means that when it goes down or up, there is a carbon.
Until here, that is what I have learned about organic chemistry. And now I say goodbye.